Hello, my name is Nicholas Lin. I am an applications engineer here at Perkin-Elmer, and I work with the Next-Gen Sequencing Applications Group. Today I actually wanted to give you an introduction to the Sciclone NGS X, as well as the software that is used to control it. So as you see in this particular slide, we have an image of the Sciclone NGS X. One of the things that are important about this instrument is how it's contained and the way we have the deck set up. The decks are actually, for all the Sciclone NGSs that we sell, have a standardized deck. Therefore, any chemistries that we automate that may come out currently or in the future, they all run off the same deck. The great part about that feature is as you go forward, your deck would never be obsolete. All the decks for each one of the Sciclones that we sell and we have distributed throughout the world have the same exact deck. Just the chemistry may be modified, whether somebody uses an Illumina chemistry or an Agilent chemistry. So what we've done is we've designed this instrument such that it's easy to use, and that basically anybody can walk up to the instrument and run, say, for example, a library prep on it or a hybridization setup and so forth. And we've done more than just integrating a lot of hardware features into this particular instrument, but we've done a tremendous amount of work in the whole user experience and working and interacting with this particular liquid handler. So I think it's really important that we look at the features of the hardware as well as the software. This next slide actually shows kind of an overview of the deck with say, for example, a library prep that may be set up. On the left-hand side, let me see if I can move my mouse here. You can actually see, and this is done as a cascading design right now, just for images of basically seeing that you can actually put 3 stacked tip boxes. So on the bottom over here where my mouse is, it's empty right now, and then this one shows a single box, a double stacked, and a triple stacked box. So in this particular section over here, where my mouse is, we can actually hold 24 tip boxes in reserve. And the purpose of that is so that way it would basically allow the user more walkaway time. Now these processes, as we run these chemistries, utilize tip boxes, and we want to make sure that the user doesn't run out of tip boxes during a process and has the most walkaway experience as possible. And over here, you may notice there's something that says 3 times thermal locators, 4 to 110. Well, on each one of these Sciclone NGS systems, we actually have 3 thermal locators that actually heat from, or cool or heat from 4 to 110 degrees centigrade. And also actually over here on this bottom right corner, you're going to notice it says thermal shaker 4 to 70. Well, that's another temperature locator. However, this particular position has a unique feature where it allows you to shake a plate. So say during an incubation or a spry cleanup where DNA is binding to the beads, that could shake at whatever temperature that you want for a specified duration of time. On the bottom right-hand corner over here, there's actually a waste chute. So when tips are finished after you've, for example, aspirated supernatant and dispensed it to your liquid waste container, at that point you'd be done because you don't want to cross-contaminate other reagents and samples. So there is a waste chute with a tray or bucket that sits underneath to collect the used tips. Now, because you may notice this deck has a lot of microplates on them, we can run a whole process without having to add microplates to them. And you may notice on some of these locations over here towards the back, you may notice that there's plates that are stacked. So when a plate or a reagent plate is done, instead of wasting valuable deck space, we actually have this on the left-hand side. You'll see it says used plate and tip box shoe. So once the plate is complete, the robot has the ability to pick up that microplate or tip box and throw it out. And then once that plate is gone, it is replaced either with a new tip box or it is replaced with a new microplate. There is actually a gripper. This is actually the main head that we use to do our pipetting. But on the left side, this little section over here, there's actually a robotic gripper that can come down at various heights and basically can grip plates, tip boxes, lids, and it's a very valuable tool in this particular setup. And over here, where you may see tips are hanging, these are 96 tips, and that allows us to, if we wanted to do a full plate transfer, we could do a full plate transfer. And this particular slide actually goes over a little bit more, a close-up picture of that recessed deck that we actually store our reserve tips. And again, you can hold up to 24 tip boxes. And over here on the bottom right corner, this actually shows, if it was empty, that's what it looks like. Now, one of the features that is very powerful about this particular instrument is you can actually load a variable number of tips. So if you wanted, like in the previous slides, you saw 96 tips loaded. So if you wanted to load all 96, you do have that ability to do that and do full plate transfers. So if you were transferring, for example, your samples to Ampure or for cleanup, you could pick up all 96 samples at once. However, if you look in this left picture, there's a single tip on the head. And so the head actually has the ability to pick up a single tip as well, based off of the tip box design. You may actually notice in the right picture this tip box. You'll notice that the edges are actually scalloped on the side. Well, this tip box design was designed on purpose so that way, if you did need to load a single column of tips or a single tip, for example, for indexing or barcode broadcast, you have that ability to basically pick up a single tip, aspirate the index adapter of choice, and then distribute them to various wells. So over here, you'll notice that there are 8 columns of tips, and then here you have a single column of tips. Again, when we use 8 columns of tips, we actually use that sometimes to broadcast reagents to microplates. Now, instead of, there's a lot of customers that we have that don't want to run a full plate. They may run, for example, half a plate or even 2 columns of plate. 2 columns of samples, which equates to 16 samples. What we do is we actually put some of our master mixes, or even if it was an A-tail mix or ligation mix, we actually put that in a column as opposed to distribute them in a whole entire plate. And our reason for that is so that way we can reduce the amount of dead volume that's required to run. As it is sometimes in the actual kits that are distributed, sometimes you barely have enough reagent for what you need to do. So what we want to do is we want to minimize that amount of dead volume that the user has to go through. So looking at the actual the platform, in here, we have two kind of like just 2 instruments, but the left one, if you notice, which is a Sciclone, it's contained basically within an environment. There are actually doors that can open and close, and actually on the back side of it, and actually on the left and right side, there is actually plexiglass that basically, once you close the doors, all your samples are contained within that environment. It's not open to just the open air and so forth. And the great thing about this and having it kind of in one enclosed system is it's basically bump proof. So if you were to accidentally shift something or move a table or need to move the system, an inch to the left or the right, there's no worry about misalignment or things not handing off properly with various components. As well as, with the way it is, that's the amount of space that it takes up. It doesn't, extend, beyond this, taking up large amounts of bench space. All right, so I just wanted to kind of give you a few slides about the user experience using the software, which in my opinion is one of the most valuable things. The software is what the user will interact with, and over the years we've actually designed interfaces to be intuitive and easy to use. Later on, I'll actually give you an intro to, I actually have Maestro, which is the control software that we use for the liquid handling instrument, and I can actually, we can actually create a sample method, and you can see just how easy it is to run the software, as well as to create custom applications on the fly if you needed. So, on this I labeled this benefits of simplicity, and I believe that when we're running this, this should be almost like an extension of what you do as a tool. If you were to run this manually with a hand pipette, it's intuitive to almost grab that pipette, load the tip, and use it. There's no real complexity in it. You just do it. And so with the automation, we've designed the software such that we can create interfaces for the user where it's easy to use, not this custom scripting language that you have to really learn, but is powerful at the same time. If you actually notice on this top right picture over here, we have the ability to create startup forms, and in fact all the methods that we develop actually have these built in. So on the user's end, they really don't need to program anything. It's already done for them. So we created this interface over here called Modified TrueSeq DNA User Interface, and depending on what particular part of the next generation sequencing protocol that they're running, we can basically add different options. So on this one it says adapters already pre-broadcasted into quadrant 1 of a 384 well plate. Excuse me. And so basically at that point the user would pre-broadcast that by hand, and that's a user selectable option if they wanted to do that. Some people do. And there's another box just below it. It says Sciclone will broadcast adapters to a 384 well plate. So we actually work in conjunction with Excel, and we can actually assign what index adapters or barcodes we want to use to specific wells in an Excel sheet. And by selecting this option, it would actually read off that Excel sheet and automatically use a single tip and actually broadcast those adapters to the specified wells. And then once the user's done, they can click the OK button, and then it takes you to the next step. Okay, and you may notice actually there's two windows that I have over here, and I only have two in this particular example. I'll actually show you what it actually looks like in the actual software in just a few moments. But in this over here, what this is almost a setup wizard. All right, so we've actually set up and we've taken pictures with custom text telling the user what do you need to put in a specified position, and the caption here says place a 384 well Corning PCR plate with a certain part number on top of the temperature locator on deck location A3. Make sure to put a lid on the 384 well plate. All right, so this actually not only gives them a text instruction, but it actually shows the user what plate does it look like. I mean, sometimes in the lab you may have multiple 384 well plates, or even 96 well plates, and it helps for a user who may not be automation savvy to be able to go up to the instrument and actually look at the picture and put that object with, when I say object, microplate, whether it's a 384 well plate or tip box or 96 well plate, in its appropriate location. And as I said, each one of these plates for the reagents, I'll show you later on in the actual Excel. We actually have reagent calculators that would actually pre-calculate any reagent that you would need to add to any one of these microplates, including dead volumes or any dilutions that you may need to make in the process. So we've done that. You essentially enter the number of samples that you want, or I should say the number of columns that you want to run. We do things by column based. And based off of that information, a spreadsheet automatically tells the user what they need to add per well in their microplate. So this is going into creating custom applications. And I brought this particular screen up with this window to show you. This is what if you were creating something custom, the deck image of how do you tell the deck or the machine what microplates are there? Is it a tip box in a certain location? Is it a 384 well plate or a 96 well plate in a certain location? On the left, you may notice there's a bunch of categories over here, and they're done by groups. So if it's a 384 well plate, it's categorized in a 384 well icon, as well as if it were a tip box or a 96 well plate. They have their own categories. Everything in the software is drag and drop. So all you need to do is basically click from the left side on what you want to drag over and drag it literally onto a location. So if I wanted a plate on location C3, I can just click it and drag it. There are things that help you organize your methods, and on the right hand side in this particular image you're going to notice this almost reminds me, it's like a filing cabinet for anything that you create within your application, and you can keep them categorized and organized basically in here. On the left hand side we have our development tools, things that you would use if you did want to, say for example, modify one of your applications, whether or not you wanted to add an extra mix step or an extra pipette step. That's something that you can actually add and customize in some of the applications that we actually develop, and it's very easy to use. Again, just as I mentioned earlier with the deck setup, it's all drag and drop operation. So on here I gave an example of if the user were to want to run an aspirate step. The user would essentially see this particular screen over here with the head device. There is something on my particular software that I don't actually have what we call a Z8, and it's an optional device which allows 8 independent channels to operate independently. So each one of those, when I say Z8, they're individual cannula that can come down and pick up independent volumes, and there are 8 independent syringes. And if you were doing a plate normalization and you wanted to do it relatively quickly, you can actually use the Z8s to pick up independent volumes of sample, independent volumes of diluent, and deliver it to your destination plate for normalization purposes. However, there are a lot of systems out there that don't actually have that optional Z8 in there, and still just use the main array for normalization. In fact, most of our customers actually do it that way, where it uses a single tip to do that normalization, and it runs perfect. Well, so this again, if you notice, it says head device over here. It gives me the choice to switch. If there was a Z8 here, I can click on that particular Z8 device. But in this case, the main array using all 96 is selected. The next screen would actually show where you're aspirating from, and assuming that we have we would have multiple plates on here. In this particular example I wrote, it only has a single plate for now. But if there were multiple plates, you can actually click on any one of these tiles to tell it where do you want the head to go to pick up your reagent. And in this plate map, this is almost like a mask that tells the user, well, where do you actually want to pick up from? If we were picking up in this example, it's highlighting all 96, so it would aspirate from all 96 wells. However, if the user wanted to aspirate from a specific column or even if they loaded a column of tips, or if they loaded a single tip, they can say go to any one of the 96 wells in that plate, which comes in handy for picking specific wells, like hit picking, for example, on that microplate. The next tab down, and as you notice, it goes from head device, deck location, generic, which has that mapping. Now we're down to volume. There's a little entry box that says how much volume do you want to transfer, what speed do you want to pipette at. Pipetting speeds are really important if you want appropriate liquid handling, as well as useful features called leading air gaps and trailing air gaps, which allow you for more control for liquid handling. And this last tab in here, in this particular menu, is telling the machine how low do I want to go in that microplate. Now, this is at 0 right now, and this where the tip is, with a graphic of the tip over the well, this is actually talking to the consumable database. Based off of the consumable that we're using, for example, if we were using a Bio-Rad PCR plate, I'm going to make this up, let's pretend that the maximum depth was 14.5 millimeters in actual depth. And these depths can actually be obtained through the manufacturer website from the producer of that labware. And essentially, because we have all that information stored in the consumable database, the values that we give for the depth are actually controlled and limited by the actual consumable depth. So if the actual depth was 14.5 millimeters, you wouldn't be able to say, oh, let's go to 20 millimeters, because that would, essentially the software is preventing you from making a mistake and crashing through anything in here. Okay, so now I actually have the Sciclone application up, and I actually want to show you the user experience of what the user sees when the application starts. So if I were to load up an application, it would basically show the title at the very top. And if I actually, this is the main program that's going to run. If I actually click this execute button, it will actually run through, and this, just as I've shown you in the PowerPoint slides, it gives you the options for index adapter broadcast. Okay, so I can, with these radio buttons over here, I can click on that top piece or the bottom piece. All right, I'm just going to click OK. And another thing, what it does is it actually validates the workbook. I know I haven't shown you the workbook yet, and I will in a moment. But what it does is it actually verifies the number of columns that you want to run, which if you were to run 3 columns of samples, and each column has 8 wells, that would equate to 24 samples. All right. If this for a reason was not correct, the user has the option to cancel and correct that, to say, oh, well, today we don't want to run 3, we actually want to run for example, 6 columns of samples. When you're done, you just click continue, and we actually have that startup interface that comes up, which actually the user can step through as a wizard. So it says place 384 well plate on deck location A3. Make sure to place a lid on the 384 well plate. Well, again, our whole goal on this is to make this intuitive and easy to use. You shouldn't need to grab an instruction manual to run this process. You should be able to just hit run on this instrument. This screen should come up and tell you anything that you need to put on any location. So I'm going to click this next in the bottom. You may notice there's a previous and next. If I click next, this will actually bring us to the next screen, which is one of our reagent plates. See, it says column 1 really has A-tailing mix, 2 has ligation mix, and so forth. And it's labeled and it's clear in the picture that this is a Bio-Rad plate. And I'll actually step through this because it's going to literally walk you through the setting up of the whole entire deck. In the process, this particular plate actually has 2 plates in it, and it says, oh, this is your peg plate. This one may have your spry bead plate with ampere in it with lid. I click next. We have tip boxes in a certain location, which is B3. We have things like your magnet, so when we want to work with the ampere and remove supernatant, we can. Ethanol troughs, and so forth. So as I step through this, we'll eventually get to the end, and it'll actually show you an overview of what the deck looks like before you run it. So we actually say place full tip boxes in the left positions, and make sure and double check that the deck and what you see here matches what is actually on your deck setup. Now when you're done, you click finish, and essentially the run will start. All right, so if I click finish, it's going to ask, do you want to start the run, and you can say yes. I'm actually going to stop this because I actually want to go into the Excel workbook and show you how easy it is for the user to control the number of samples and to be able to calculate how much reagents to actually add to the plate. So if you noticed over here earlier in the confirmation screen, it says, oh, I was running 3 samples, and it's actually reading this Excel sheet and what we put over here. Over here in this particular section where I'm kind of highlighting, this actually tells you this is representative of the plate and what you need to add. So in this case for the resuspension buffer plate, which it tells you it's in location C2 on the Sciclone deck, as well as what plate it is, it says you need to add 45 microliters of this particular reagent to the plate. And once you've done that, that's it. Put it aside, and you follow that those little pictures that I just showed you earlier, and you set up the deck. So each one of these has calculations that are pre-made. So even things like N repair mix for anything that we need to add to it. There's actually in this particular section over here, there's actually calculations that we already pre-make for you. So over here, based off of 3 columns of samples, which is 24 samples, we need 931 microliters, 931.8 microliters of the N repair mix from the actual tube from the manufacturer, depending on, of course, what chemistry you're going with, and then 233 microliters of resuspension buffer. Once you mix that up in the tube, you would actually add the N repair mix to this particular plate, which is column 8, and it says, oh well, from that particular tube you need to add 140 microliters to each, and we do this for all the reagents of the plate. So for A-tailing mix, ligation mix, your PCR master mixes, all of that is essentially written out for the user, so that way they don't even have to think about what they need to add to the plate. It's just done for them. And again, the whole process in this is to reduce the amount of confusion and the amount of error that a user could introduce into this large, complicated process. And we've really spent a lot of time and effort into basically reducing that, so that way, in the end, the user could have a better experience. You can have more reproducible data, and at the end of the day, the user's not frustrated with, what they just ran. Another thing I did want to show you on this particular sheet was, I know we said the number of columns were 3 that we want to run for 24 samples. I'm actually going to make that 6 in a moment. For example, let's take a look at the N repair mix, since we looked at that earlier. And basically, it's telling me I need to add 931.8 microliters of the N repair mix and 233 microliters of the resuspension buffer. Let's actually increase this to 6. So I'm just making this number 6. All right, and when I do this, you may notice that the N repair mix volume also increases, and now it shows it's 1,863 microliters of N repair mix, and the resuspension buffer volume went up as well. And if we actually look at where we actually put it in to the destination plate, you're going to notice it's now 185, and it also says, well, now that we're running more columns, it actually says you need to add 95 to the adjacent column, which is column 9. Okay, and if you notice on this one, if you were to, for example, to do a full plate, column 10 is empty right now because it doesn't need to, go into those particular wells because you don't have to worry about overflow or anything. So it's at 0 right now. And even this, when we're adding Ampere to its plate, you notice if I said 6, it actually highlights, or not highlights, but populates and tells you how much ampere do you need to add to each one of those columns. Now, this particular one is for like library prep, but each one of these, there are actually tabs on the bottom for library prep indexing, post-PCR, a library spry. So if I were to modify any of those values, if I wanted to make that from 3, which again, only 3 columns are populated here, to 6, all right. As I do this, you may notice, the rest of the plate populates over here. To normalization setup, hybridization setup, as well as any capture steps that you may use. That way, if you need any bead wash buffer, binding buffers, they're all added for you, in this whole entire suite. But yeah, so this is essentially what the user would interact with to basically do setup of their reagents. So with the combination of this worksheet, it helps prepare the plates, and with the startup screens that you see within Maestro, with that user display, it tells the user what you need to do to set it up, and once that's set up, you hit go, and whatever process, whether it's library prep or a post-PCR cleanup step, is done automatically. The user doesn't have to do any programming in here. It's already set up. All right. Well, enough of how the user experience is. Let's actually go into, because you can actually modify these methods. Let's start with something simple. Let's actually start with fundamentals. I'm actually going to create a new method. For example, I'm going to close this. I can go to File and then New. Right? And over here now, it's a blank setup. So if I wanted to do, say, a simple plate transfer, I would need like a tip box, a source plate, and also a destination plate. All right, in this simple example. So let's add a tip box. So things are done by categories, as I mentioned to you earlier in the PowerPoint slides. So I can click this tip box and drag it, wherever I want. Let's pretend I actually want a tip box at A2. If I drag and drop, I let go. It actually shows the tip box in that location. I can actually double click it if I want to, and I can give it a new name. I can say tips or tips 1 in case if I have multiple tips. Okay. Next thing is, let's go down to this location for 96 plates. I'm going to add a plate, let's say in C2, and let's actually add another plate in C3. Over here, I'm going to actually double click this, and let's call this one, for example, source plate. Just something descriptive, to give, as you guys are programming, an idea of what plate it is. As well as over here, there's a drop-down box that actually shows a library of all different types of manufacturer plates that we've already built into the consumable database. This particular one, let's use, for example, as the Bio-Rad PCR plate, which is a common plate that we use in all our next-gen sequencing protocols. All right. I'm going to actually do the same for the destination plate. Let's actually label this destination plate, and I'm going to go back down to this box and select that Bio-Rad plate. Now, for example, if you did have a custom piece of labware that you're trying, or you would like to add to this list, you can absolutely add this to the actual consumable database. Okay, so now this is set up, and if you notice, again, it was all drag and drop, no fancy programming in there. In fact, if I wanted to move this plate, this destination plate, from one location to another, I can actually click, drag it, and drop it. And if there was something that it was already linked up in a method, it would actually reflect that change in the method, so the user doesn't have to make that change. Okay. This is, again, the information window, and again, it's just the filing, basically like a filing system for all the different methods that you may have. And this is the coding window, which is, right now it says main because it's your main coding window. I shouldn't say coding, it's more like you're not coding in a sense, but you're dragging and dropping the number of steps that you need to complete that process. So again, what I want to do is I actually want to first load tips, because I want to transfer samples from the source to the destination. So I'm going to say load tips. Okay, and when I drag and drop that, it shows the main array. Oh, and actually on this particular simulator, and I'm sorry, when I created that PowerPoint slide earlier, I didn't actually have this enabled in the graphic, but in this particular simulation that I have on my laptop, I can actually select the Z8, and if I wanted to do every other column, or a single channel if I want, I can actually have individual cannula come down or every other cannula come down. I can select none or all. In this case, I'm doing a simple plate transfer. I'm just gonna select this main device. I can go to deck location, all right, and right now I only have one tip box, so it's only gonna let me load tips from here. For example, if I were to click on this microplate, it wouldn't let me. It actually gives me a message that says select a valve location on the deck for this operation. So there are things that are built into the software that prevent users from making errors. And then on the tip box, I'm loading the whole. If I wanted to load a column or even a row or even a single tip, I can. But here I actually want to load the whole entire tip box. When I'm done, I click OK, and if you notice, I actually have my full first line in here. And in here, what we just went through is it says, all right, well, I have a tip box at A2, and it's saying it's loading the tips. And don't worry about all this text. It actually comes in handy, if you need to kind of glance through your method later on to say, what is it doing in there. Now, what we want to do is we want to actually aspirate from the source plate, which is in C2. So all I'm going to do is I'm going to drag and drop this aspirate over, okay, and I just drag and drop it. So I'm using this head device, which is the main array, and it's labeled it's called main array. I go to deck location, and I want to select my source plate. And in fact, this is why it's handy to actually label the consumables that you actually add to your deck, so that you don't get confused that whether it's a destination or source. This is the plate mapping, very similar to what I showed you in the tip load. I'm doing all 96, so I'll skip past this. Volume is how much do you want to add. So if I wanted to transfer, for example, 50 microliters of reagent X, I can set the speed to whatever I want. I may want to say, let's pick it up at 60 microliters a second. And in fact, I can add things like leading air gaps. I may want to add a leading air gap of 4. And you may ask, what is a leading air gap? And I kind of relate this to if you were using a manual pipette, and let's pretend in the manual pipette you picked up 50 microliters. When you actually bring it to a tube and you dispense, you hit the first stop on the pipetter, and that'll actually dispense your 50. But most of the time, you'll always push a little bit more, and it may be forcing against a spring in the pipetter, but that basically forces a little bit of air to come out, and that little bit of air is what we call the leading air gap. So basically, I'm telling the instrument, let's push a little bit, like 4 microliters of air in, just to make sure that everything's out, in case is viscous. And then we have these things called trailing air gaps. So in case we're working with anything that may drip easy, maybe an ethanol. In fact, we use this in the cleanup process, spry cleanup process. When we're aspirating ethanol, we actually pull up a little bit of air to basically create a barrier between the bottom of the tip and where your ethanol is as it's traversing across the deck. Last thing is tips positioning. This is how low in the plate do you go. Again, this is completely incorporating the consumable database and some of the settings in the background. So if I were to say, let's go down to 10 millimeters, okay, this would actually come down and it would show in relation to what the plate setting is. This is what the tip would look like at 10 millimeters in that microplate. And then you have different things like approach and retract speeds. So if I set that to 20 and 20, this allows you to go in or out at a certain speed. Now, as you're going left and right and across the deck, you may want to go at 100%. Library prep or even capture steps. These are several hour processes. So you want to go at 100% across the deck if you can. However, when you're actually doing your fine liquid handling, you don't want it to go in your liquid at 100% and come out at 100%. For example, Ampure has a high viscosity. So if you were even to take a manual pipette, put your manual pipette into the like a tube of Ampure and pull out really fast, we're going to notice that Ampure actually is sticky and it sticks to the side. But if you pull your pipette out slowly, the surface tension of the Ampure will actually wick off any of the residual ampere on the outside of the tip. And this goes the same for the automation in here. When I'm done, I can click OK for aspirate. And then we also have a dispense step over here, okay, because we want to dispense it to our destination plate. So I go to destination, I click on this particular plate, which is under C4, and it's labeled destination. I'm dispensing in the whole entire plate, so I can skip through this. Volume. Now I know I aspirated 50 with an air gap of 4. I can actually click on this option called dispense all, and that will actually get rid of everything in the tip. And at that point, I can say, let's go back down to 10 millimeters into the plate. I can go at a speed of 20% to go in and come out. And we also have this option here that I didn't actually show you in the aspirate, which also it has it. But you can do a tip touch if you wanted. So if you wanted to do a certain well travel, I can say travel 2 millimeters in the well to do the tip touch, and maybe, let's say, delay for 1 second, so that way if there was a droplet on the side of the tip, that it gives it a second for it to kind of adhere and maybe kind of like fall a little bit into the well before actually pulling the tip off the well. And I'll click OK. In fact, one thing I actually forgot was we need to eject the tips next, is to add a waste chute. And so what I'm going to do is I'm actually going to add that into my main layout. So there's something called tips waste chute, and I can actually drag and drop that over here, and this is our tips waste chute. So if I go back over to eject tips, all right, this would allow me to actually select this waste chute. I click OK, and essentially my method is done on this. And if I wanted to save this, I can actually click on File, and then I can say Save Application. All right, and I can give it a name called Simple Transfer Demo. Okay, and essentially that actually saves into the actual application database. Now, I know this was very easy. And it was all drag and drop in terms of the nature of this. In fact, I know I had mentioned it earlier about moving consumables on the deck, and I'll actually move this from C4 back to C3. Okay. Now, if I clicked on the dispense step, you're going to notice that this deck location also now takes into account that you've moved it. So essentially, the user doesn't need to go and actually reflects the change based off of what you've dragged and dropped. Alright, I'm going to click on that save one more time. So, there is a feature though, if you did want to get fancy and create a unique user experience. What you could do is you can actually create startup interfaces, very similar to what I showed you in our next-gen sequencing automation software. So let's do this, and this is something that I've worked with a lot of liquid handlers in the past, and this feature is one of my favorite things. If you do want to do any coding in the background, again, you don't need to if you don't want to, because you can completely write a whole entire application without any programming. But if you wanted to add a very fancy effect to it, you can. So under Tools, there's a feature called VBA Editor. All right, and this basically brings in a development environment. So that way, if you did want to code something, for example, if we wanted to control the volume that the user aspirates, right now what we've done is we've actually hard-coded this value. I can actually double-click on aspirate to 50 microliters. All right, we may not want to do that. We may want a variable where we actually prompt the user, that says what volume do you want to add to it. And there are many ways you can prompt the user. I'm just going to give you a very simple one. So let's do this. I'm going to actually drag this Visual Basic design environment, make it a little bit bigger. If I actually right-click on this area and I say Insert, I can say Insert User Form. And this basically brings up this blank form. And in fact, if I were to click this Run button, this looks like a Windows program. All right, something, again, there's nothing here right now, but that's something that we can certainly populate and add like information to it. So if I close this out, we can add things. So for example, if we wanted something like a title, we can actually drag this thing called the label on. Okay. And these things can be resized, and I can actually type sample user input form. You can click this. These are actually properties of that. So if I wanted to, for example, make this particular font a little bit bigger, I can say let's make that 16, just so that way it has a little bit of a presence. Over here, I may actually put one more label. I may say, all right, well, let's enter a volume, okay, to use. And here, there's different boxes over here. There's things like text boxes, combo boxes. But let's put a box here, which allows the user to basically enter a value into this box. And then in the end, what we need is actually like a button, okay? And right now it says command button. But a lot of times, maybe we'll change the caption of this to say click to continue. All right. And all these are movable, resizable. So if I don't want this form to be big, I can keep it small. In fact, this user form, there's a title up here. Let's actually get, change the caption over here. So when I click on this particular form, it, gives me properties of that form, and I can change this to demo user interface. Okay. And again, when I click this play button over here, let me see. This brings up this particular form, and it's something that we can interact with. People are familiar with Windows and forms. There's no special coding that they have to do, on the user's perspective as opposed to the developer's perspective. Okay, so what I want to do now is link that box, whatever I type into this box, to that in Maestro, this aspirate step. What I'm going to do is I'm going to create something called a variable. Okay, so let's create something called volume over here, and this we can actually plug in this value here. So I'm actually going to I'll just copy and paste that name, because we're going to be using that in just a moment. I click OK, and now this is linked up. This is a variable. Okay, now that I have a variable, I can actually double click the aspirate step. Instead of hard coding it at 50, I can say, well, let's base it off of whatever we put in here. I know it says 0 now, but that's going to be populated with something. And now this no longer says 50, and it says volume equals. So when this step runs, it's going to look at that, whatever value that is in volume. So if I just go down and click OK. For example, if I were to manually change this to, say, 20 in this box, all right, now this says 20. When this particular aspirate runs, it's going to say, what is the value that you have in this volume? And it's going to say, oh, my value is 20. Okay, so I'm going to take that volume. Okay, well, let's go back to the actual coding window. This box that's selected over here, when I click on it, it says text box 1. All right, so when I double click this code over here, there's actually one line that you really need to write down. There's nothing too special about it. You can write it down, and I've had a lot of users honestly surprise me and create these amazing interfaces. So this one I'm going to type Maestro, and this and see, when I hit a period over here, there's something called IntelliSense. So I'm going to say set global variable value, because we set a global variable value. In fact, it tells you, all right, enter a variable name a string, and this one was called volume. All right, and the value is textbox1.text. So whatever the text box says, I'm actually going to say unload me to basically close out that code. Okay. So this is called user form 1. I just need to add one more thing in here. I'm going to say, okay, I'm just going to add something called user form. All right, dot show. All right, and the reason why is I know what user form is because this is called user form, and when I double click it, this is the title of it. And they're all drop-down boxes that help you do this. So in the beginning, if I want, I can actually add this thing called, or this option called execute VBA macro. So if I were to put that up top, it shows my method that I created. It says show UI, and in case you're wondering what UI means, it's user interface. And really, you can give whatever name you want. I just chose to abbreviate. So when I click this in the beginning, if I were to click this run button, all right, you may notice this is that form that comes up, and in the background it says 20. Well, let's make this, for example, 70. All right, and when I click continue, you're going to notice that, and this is, in case you're wondering why I get the screen, it's because I'm actually in Simulate and I'm not connected to an actual instrument. But what I want you to look at is, let's take a look at the volume now. So I entered 70 and now it reflects 70 in this variable box, and so when the method runs, it's going to look and it says I need to run at 70 microliters, and it just does it. You can do this for a lot of steps. Anything that actually has a for example, I'll go back in here. Anything that has this icon, which is a V, it stands for variable. You could think about what you can create on a user form that you can control at a certain aspect of your method. You can control even like columns, rows, because they have the V's here. Volumes, you can control speeds, how much air gap, as well as the depth of the tip. So if you wanted to control using a user interface, that you may create, you can just click V and make that happen. Okay, let's see. I actually want to bring up that error screen that you saw, because there's something that we have in the software called error recovery. And I know right now I'm just bringing one up just to show you some of the options. But we have, if you notice on the actual PowerPoint slides, and let me see if I can actually bring one of those up. Let me see. So if I go back up here, and I don't know if you can see it, but there are doors here. These doors actually, they have optional, you can turn them on and off. You can enable the left or the right one, or shut them both off. But when I say enable, it enables like a safety switch, so if you were to open the door, you can actually have the method stop automatically, and you would be prompted. It would say door is open instead of what my message is saying. And at that point, if you wanted to check something or inspect something, you have the ability to retry that move. You could skip that instruction if you wanted to. You may say, all right, I already moved that particular plate because I inspected it. You can skip it, or you could stop the execution completely. You also have things like access to what we call device control. So if you wanted to control any aspect of the gripper that moves the lid, or in the microplates, or even Z8 functions, you do have that ability, as well as the thermal locators like 1, 2, 3, which are the fixed locators, and this is the shaker, and you may notice there's different shake options in here. But yeah, so in general, this is the Maestro user experience. Again, if I were to load up a method from scratch, just to kind of recap on how easy it is, you load the control software. Right now I have nothing. The user clicks on File, Open. For example, they load a method, they click it. All right, so what happens is it loads in the background. All right, and at that point, all they need to do is move this up, click the Run button. Okay, and then it prompts you again with that user screen, and then it verifies the number of samples to make sure there's no error in there, and then it literally goes through these startup screens until you get to the very end. Okay, and basically you're done. I actually skipped past one, and you may actually notice that I actually have a flower in the background, and I actually had used that as in a demo to show that if for whatever reason you needed an extra picture in this particular startup screen, or you've customized your application, you can actually just drag and drop pictures into a specific directory with a text file, and it would actually be added to this particular menu system. Well, just click Finish, and you say yes, and essentially the machine will run whatever process that you want, and at the end of the day, you collect your sample. It tells you where your sample is, and usually they have them end up on a locator that's at 4 degrees, since each one of those locators can actively be heated or cooled dynamically through the method. Just want to say thank you very much for your time, and hopefully you found this useful. If you have any questions, feel free to contact Burke and Elmer about this. Thank you.